we have an interesting topic to discuss. So for that, as the speaker, today we have Lakindu Hewawasam. He is a software engineer at Enlia and also AWS community builder. And today he will be talking about a game changer for building serverless apps with IaC and microstacks. So Lakindu, over to you. Lakindu, we can't hear you.
Sorry, it's my first time using Zoom, so we're just having a bit of trouble finding out how to share, how to unmute myself. So sorry about that. Well, let me just get rid of all of this. Yeah. All right. Am I audible and can everyone see my screen?
Yes, Lakindu, we can hear you and we can see the screen as well.
All right. Yeah. All right. Thank you, Jamirai. So yeah, today, as mentioned, I'll be talking about building serverless applications using infrastructure as code and microstacks. So microstacks is quite a new concept. So I'll just be walking you through it and just talking to you about how it works, what you can do with it, and how you can use it. So actually, before diving into the content, let me just give you a brief introduction about myself. So as Shamira mentioned, so I am a software engineer and I work at Enlia. And apart from that, I'm also a community builder in the serverless category. And in my free time, I like to make technical content on YouTube, mainly AWS related. And I like to write as well. And when I have a lot of free time on my hands, I like to contribute on Stack Overflow. So let's just dive right into the content. So in this session, first I'll be talking you through about infrastructure as code in general. So we'll be talking about what infrastructure as code is and what you can do with it and why it came to be. And then we'll also talk about the several infrastructure as code tools available out there for developers that are practicing serverless. And we'll be focusing on one topic in general, mainly Pulumi, and we'll be comparing it with other familiar concepts like AWS CDK. And I'll be walking you through how you would generally structure a code base for an AWS serverless application with infrastructure as code. So this is typically our day-to-day monolith structure. And then I'll be talking to you about microstacks and how it works and what you can do with it. And finally, when you should consider a microstack. And we'll be ending it off with a small demonstration on building our own serverless backend with microstacks using Pulumi. All right, to get started. So I think at some point in our career, we might have seen an architectural diagram as similar to this or as something much more complex than this. So you can see that this kind of architecture has a lot of components on it. So you have an API gateway, you have Amazon Cognito, you have Lambda, you have DynamoDB, and you have SCS, SQS, and all of those serverless infrastructure working together to create a fully powerful backend. Now, let's just go back in time for a bit and let's just see how we would generally go about provisioning an infrastructure like this. So first of all, our most trusted would be the GUI. Now, how would we do it? We would generally just go to the AWS console and we navigate to each of these services and then we'll just hit a button or two and then we'll just put the parameters and bam, you're good to go on that resource. But let's just say that you actually manage to go to each of these services and provision these one by one. And let's say that your team lead or somebody gives you another requirement saying that, hey, can you give me this same environment on another region or for another client, I want the exact infrastructure. Can you copy it for me and give it? So then what do? You have to again go to these services in a different region and then start provisioning it one by one. So these are all repetitive actions that we do. So this significantly harms your productivity because you have to spend 1 to 2 hours just finding out where these services are and what where the buttons are and all of that. Not only that, but you have to maintain a lot of documentation. For example, if you're maintaining a table, you have to specifically say, this is the place where you go, this is what you do, this is the parameters you enter, etc. and all of that. So that brings on to my next point. Now let's just assume that you have a new developer joining your team. So what you do is you hand over the documentation and let him or her work on the infrastructure. And then, I don't know if you all are familiar with this, but recently, I think final counting last year, AWS went on an entire UI redesign. So each of their services got a new UI look to it. So then what will happen is your developer will look at the documentation you have made and then look at the UI and he'll be clueless. So then he'll be coming to you and you'll have to fix it up. And then it's another mess. So it is not an ideal situation. These are all quite problematic. But let's just say that you managed to solve this problem and you moved on. But then your new developer, he's working on this infrastructure that we see on the right. And then what he does is he sets up a cognito authorizer or the cognito user pool. And then he suddenly forgets to wire up some kind of a trigger. So it can be like an post confirmation trigger or a pre-token generator. So what happens in those scenarios is that then your QA engineers or your testers would suddenly open up the app and be like, hey, this is not working. Why isn't it not working? And then you'll get the report back again and it'll be like, it worked here, but not there. So then you'll again spend a lot of time researching and finally find out that this is just some developer made bug because you missed on some UI control over there. So in a way that all of these actions are manually operated by someone in our day-to-day job. So that means that there is no way of automating this process. So you can't set up a CI/CD pipeline or you can't test your infrastructure in a pipeline. So there's no way that you can have any kind of automation. So what can we do about it actually? So there are mainly two things. So as we progress through time, we came up with different ways. So for example, you have CloudFormation that helps you provision resources directly from a configuration file and you upload it onto CloudFormation stack and then it deploys it. But I think we all know that it's really hard to provision infrastructure with CloudFormation because you need a really long syntax to provision some really small resource. So I think many people who worked with CloudFormation knows about this problem. And then what happened was people introduced APIs to help provision this infrastructure directly from our code. Now that helps significantly. And I think that if you take a look at architectures these days, they drastically change, they rapidly evolve as your application grows. So for example, you might have a synchronous flow 5 years back, but today you might want a completely asynchronous architecture where you want all of your AWS serverless infrastructure to scale independently. So in cases like that, relying on a UI is not that ideal because you'll have to navigate with service, you'll have to figure out what to do before I do this, and so on and stuff like that. So that is where infrastructure as code comes into play, basically. So infrastructure as code is simply, in simple words, it's just using or declaring infrastructure in a code and provisioning it and managing it directly through your code base. So you no longer need to interact with the UI, whereas you use configuration files to automate your infrastructure deployment. So as you can see on the right side, there's a small figure. So this is just a serverless framework where you declare a simple Lambda function and that actually provisions an API gateway along with it as well. So there it's just two jobs. You did it in this few lines. So it's not that hard with infrastructure as code. And what happens when you do stuff like this is you enforce something called a single source of truth. So regardless of which region you're deploying your resources on or which infrastructure or which stage you are deploying, it can be the dev, prod, or testing. So everything is referred from a single point. So you know that everything you do comes from this single entry. So nothing can go wrong. And with this, you actually improve productivity because developers no longer need to worry about a UI or anything. They can directly code it out. And this also results in faster deployments because you no longer have to waste time finding for these services or running lengthy scripts or typing it. And it also improves the ability to test this infrastructure. So you can hook it up to a CI/CD pipeline, and then you can test it on your continuous integration flow. And not only that, because you have a single source of truth, it also enforces code reusability. You don't have to type or you don't have to reduplicate your code to maintain multiple environments. You can just directly hit branch off to a new stage or new region, and then you can deploy it right there with the same code. And by doing so, you have less errors. So you don't miss out on triggers because everything is coded. Nothing, anything that is in the code is provisioned. Nothing misses out, nothing like that. So that way it increases your productivity and your efficiency. And finally, this is, I think, something that many of us like. You can roll back on deployments. I mean, most of us here have at some point in our career, we have messed up something on the production application with just one kind of a parameter that messes up the entire deployment. I mean, I know I've done that once. So with infrastructure as code, what you can do is you can just, if you're on version control, you can just revert a commit and then redeploy the infrastructure again. So it'll update the diffs properly and you are back to where you were. So in that way, infrastructure as code really saves the day for us developers. And when you take a look at how infrastructure as code can be utilized for serverless, so mainly I'll start off with the introduction. So this is using CloudFormation. So CloudFormation was one of the first tools that allowed infrastructure provisioning on AWS, but it uses different syntax using YAML or JSON files. And I think this is not quite ideal because it's quite complex to declare infrastructure. And then you have the serverless framework, which again utilizes CloudFormation behind the scenes, but it provides a more abstracted view for us. So we don't have to worry about the additional added complexity, where we can just start coding our infrastructure out and let the underlying process that is done by serverless framework to carry out these underlying complicated processes. And then you have the AWS SAM CLI, or the serverless application model. So with this is another recent offering by AWS actually. Again, it utilizes CloudFormation, and I highly recommend it if you are just getting started with the AWS ecosystem, because it's a quite abstracted interface and it allows you to code it out again. But all of these resources, all of these tools that we use, you have to learn some intermediary language to get used to it. This is where tools like CDK comes into play. So CDK is something that Amazon developed that it basically allows you to use programming languages such as Java, JavaScript, or TypeScript to directly provision your infrastructure. But behind the scenes, it still uses a CloudFormation stack to deploy it, but you get the added versatility and the efficiency or the easiness of using your day-to-day programming languages combined with object-oriented principles, something that we all love and use to manage your infrastructure. And finally, on the widest end of the spectrum is something called Pulumi. Pulumi is also another infrastructure as code tool, and we'll be taking a look at this further down the slides. So yeah, Pulumi. Pulumi is nothing more than another infrastructure as code tool. And the main advantages of this is that it is open source. So I think that all of us, even if we have an issue with this CLI or this service, we can always contribute to it and get it fixed. And it works on any platform. So it's not cloud dependent. It works on Azure, G-Cloud, and AWS, and many other more cloud resources. So you don't have to worry about being stuck onto one cloud vendor. You can easily use the Pulumi service to manage your cloud infrastructure across several clouds. And it uses your familiar programming languages. So again, it utilizes programming languages like Java, F#, C#, and TypeScript, and so on. So you name it, they have some kind of plugin that allows you to use that language. So I think that in a way that's quite helpful for us. And it also offers really well-tested APIs. So Pulumi offers its set of frameworks known as the Crosswork library. So in the Crosswork library, what you have is, it's something like the CDK constructs which AWS itself offers to us. So they have engineered best practices and taken account the best way to maintain this infrastructure. They provided an abstracted interface or an abstracted class that we can use to provision this infrastructure really simply with just a few lines of code. And finally, it has the ability to monitor applications directly from your CLI. So when I say monitoring, this is not in a way that it offers distributed tracing or something like that. It simply offers you to listen to CloudWatch logs directly from your CLI. So for instance, let's assume that you have an API gateway that invokes a Lambda that talks to DynamoDB, and there you have another stream, and then you might have SQS, SNS, or another service polling a Lambda and then doing something else. Now, there are a lot of places where an error could happen, and it's really hard to figure out where you have to look in order to find the error. So with Pulumi logs, what it does is it actively listens to CloudWatch, and whenever it fires an event or whenever a record is logged on to CloudWatch, it directly pulls it onto CLI. So you directly have information on the error, you can directly go to the Lambda and then solve it out from there. So this figure right here. So as you can see, this is the Pulumi syntax. And what we are doing here is we are actually creating an API gateway and we are hooking on a Lambda. So as you can see, it just takes less than 20 lines to create an endpoint with business code. So this is pretty simple in a way. If you consider infrastructure management, it's just few lines and you already have a fully working backend API. So Pulumi versus CDK, where do they stand? Now, I think there are three main ways in which the Pulumi and the CDK stands out from each other. The first one is the deployment engine. Now, CDK, though it uses a programming language to type the syntax, behind the scenes, when you hit CDK deploy, a transpiler executes the runs and then it converts your programming language code onto CloudFormation template or CloudFormation scripts, and then it deploys it on the CloudFormation stack. So in a way, this adds a bit of time depending on how large your stack is. But Pulumi, on the other hand, it uses your native programming languages and it uses its deployment engine to directly communicate with the cloud vendor to provision your infrastructure. So this removes that added transpilation process. So in a way that saves time a bit. I've noticed that it saves time when using it. And then there's IAM management. Now, in CDK, usually when you have a Lambda and you want DynamoDB to talk inside that Lambda, you'd have to provide some kind of grant, write access or read access to that DynamoDB table. This is an added complexity that developers have to do. But what Pulumi does is, by default, it hooks up certain IAM policies onto your Lambda function. So it creates a role, the execution role, and then it assigns, for example, the DynamoDB policy. And if you're using SQS, it hooks up the SQS policy. So it recognizes the services that you use, and then it creates IAM policies that help you sort it out. So you don't have to manually manage IAM policies anymore. But I should mention, this is not that good. So Pulumi gives full access. It doesn't restrict onto a specific resource so that you have to do manually, but I still think that it's an added advantage because you don't have to worry about infrastructure, you don't have to worry about maintaining IAM policies on your code. And finally, this is a big shift that Pulumi started. So this infrastructure referral is, we are mainly talking about infrastructure as code. But Pulumi started a trend which involves converting that infrastructure as code into something we can call infrastructure in code. So what does this mean? So let's take, for example, if you were passing a Lambda, in a DynamoDB table name onto a Lambda function, you would use environment variables. You won't hard code it, because if you hard code it, you can't replicate it across different environments. But with Pulumi, what you can do is, these infrastructure, since you code it out, you're using a class. So you're creating an object of a table class, for example, a DynamoDB table. And these classes have methods on it where you can just simply call a getter on the code itself, and then it resolves those values at deployment time. So during deployment, Pulumi, the deployment engine will track your stage and the resource that you use, and then it will identify the stage that you are in, and then it will swap out the variables based on the deployment stage environment that you're deploying it in. So in a way, this is one of the biggest reasons that I highly recommend switching over to Pulumi and the concept of microstacks coming into play. So with that, let's just take a look at these two figures. So on the left, far bottom left, so you can see that this is how we would declare a Lambda function in CDK. So you'd have your environment and you'd set up your environment variables and pass it on to the Lambda. And from there, you'd normally, how you normally access environment variables, and you take it from that. But if you're using something like Pulumi, so if you can notice on line 49 on the figure on the top right, I have actually called the users table, and then I've accessed the name attribute, and then I just called the get method. So with that get method, what it does is, during deployment time, Pulumi will refer the proper infrastructure or the proper table name onto the code. So you don't have to worry about passing infrastructure names or infrastructure earns or aren't directly from the environment. You can just code it out and let Pulumi resolve it during the deployment time. So after you get started with any infrastructure as code tool, or in general, you typically follow something we call a monolith model. So what exactly is a monolith model? So a monolith model is where you have your separate in each of your infrastructure available in different directories in your same individual project. So if we can see that we have an API gateway here, a database which has possibly DynamoDB or any database that you prefer. And you can have more direct subdirectories where you have Cognito, SQS, SES, so S3, and all of those AWS infrastructure services on that single monolith project. And with this, it actually gets the job done up to a certain extent. But as your project starts to scale, you might start noticing some several issues. But that does not mean that this approach is bad. So if we take a look at why this approach is good and bad, these are some of the few reasons that I actually experienced personally. So the first one is you have much more simpler code sharing. So what happens with simpler code sharing is, since all of your resources are present on one project, you can directly refer these resources across your directories just by exporting and importing it onto your required directory. That's pretty simple. And then it's pretty easy to manage it because you don't have several projects. You don't have like 10 to 20 different projects where you don't have to look at it. Where one or two developers, they don't have to specifically go to each repo and then monitor it there. They have access to the entire application in just one repository. So in a way, this makes your project easy to maintain. But the maintainability comes at a cost. This is the first con of this maintainability is longer deployment times. So this is some issue that you face with most common IaC tools out there. So for example, all of these tools, when you deploy it locally, all of these tools assign some kind of a deployment ID and push it up with the service and sync it up during the deployment times. Now, assume that you have 2 to 3 developers working on your project. So in cases like this, when one of us deploys, the deployment ID gets overridden on our end and on the cloud side, on the service, on the deployment engine. And then when your other team member deploys it, again, the numbers, the deployment IDs there can be mismatches between these IDs at certain cases that can actually cause your entire stack to get updated by the deployment engine again. Now, this is just how these engines work. And there can be certain scenarios where this can even lead to really lengthy deployment times. And this main drawback of it is there is no security. I mean, you can't restrict your particular project onto several users. So for example, if you have a DynamoDB table, these are sensitive infrastructure. You have stateful data on it. You have core or your application needs to work with this kind of data. So if the person who needs to get access to it, or if the person you don't want to get access gets access to these infrastructure, it can be quite deadly. They can even delete the entire backend on your databases, and you might lose all of your customer data or something. So in a way that you don't have security, because once you give access to one resource, everyone has access to everything. Now, this is where we switch it up and move on to microstacks. Now, the solution to all of these issues, security, independence, and your deployment times, these are all solved by microstacks. So what exactly is a microstack? So microstack, even though the name sounds fancy, it's quite simple actually. It's just you take your large Pulumi project or your large single stack or your single monolith project, and you break it down to several micro projects. So these micro projects are another stack. So these are basically individual projects where you take your single project and you split it down into the simplest unit where it's really easy to manage. So if you take a look at this table or this diagram, so here you can see that this can be our monolith application. So we have here a microservice and API gateway. And on top of that, we have our DynamoDB tables, our SQS queues, and our entire backend is managed on this single monolith application. Now, if you were to split it up into microstacks, so based on what we understood, it's essentially splitting your project across multiple different smaller projects. So if you take microstacks into play, what microstacks does is it breaks down your infrastructure. So you can determine how you break it down, but I will also share some insights on what's the best way to break this infrastructure down. So you can have one a project where you maintain your core application infrastructure. So this can be like your SCS and your DynamoDB tables, your SNS topics, or your SQS queues, and your IAM or Cognito user pools, and etc. So all of your core application infrastructure, you could even have a VPC up in there if that's what you want. And then you could create another project that deals with your API gateway, mainly your Lambda functions or your microservices. And you could manage it from there. You could have these two stacks communicating with each other to share the required resources from your core infrastructure to your application. And then you could use that way to still work the same application, but this time it's instead of one large project, you have two simpler, less complex projects. So I've touched upon this a bit in the previous slide, but the way they communicate is from each stack or from each project that Pulumi offers, you can essentially export resources. You can export URLs, you can export names, you can export ARNs, you can export earns, you can export literally anything that each resource can output, you can export it from your stack. And once these resources gets exported, you can import these resources across several projects. So they have to be located within your Pulumi account, these projects, and you can directly import these projects or these resources onto your other substacks. And that way, once you import them, you then have the imported information on your microstack. And what you can do is you can refer these imported variables on your code in your sub-services in that microstack. So for example, if you take a look at this, so we have DynamoDB exporting the table names, and we have the API gateway importing them. And from that imported variable, we refer directly on our code using infrastructure in code. So you can see how this all links up, how infrastructure in code, how microstacks, and how exporting, and how all of it perfectly lines up with the development process and how it simplifies everything for us. Now, even though everything I spoke about seems pretty interesting with Pulumi, there are a few cons of going with microstacks as well. But first, let's talk about what advantages it brings to the table. So firstly, you get a really fast deployment times, because now, rather than having one single project, you've split your project up into several different smaller projects. That way you have small number of resources across each stack. And when you deploy it, even if it performs a redeployment, you still have a really low deployment time. So you get faster releases as well. And secondly, you can align each stack with Git repos. So actually points 2 and 3 align with each other. So if you have a separate Git repo for your API gateway and you have a separate repo for your core infrastructure, and you maintain two different stacks there, you can give certain access. You can give, for example, your senior engineers the access to the core infrastructure, while you don't give access to a DynamoDB table to your junior developer or something like that, or that however you fit your use case onto it. So in these kind of cases, you don't necessarily have to expose all of the infrastructure to everyone. So you can restrict who sees it and who can actually deploy it. So in a way that adds security, and you align your entire infrastructure with several Git repositories. And secondly, you have, even though it always talks, it sounds good, it's not something that I'd recommend for really small development teams. So for example, if you are in a development team of about 1 to 2 people or 1 to 5 people, maintaining 10 to 15 different stacks is not ideal. Because for example, let's say that you have some kind of shared utility library that you are using across these stacks. So if you make a change in one of these utility libraries, you'd have to ensure that it's syncing up with all that. Or if you have some model classes, you'd have to sync it up across each stack that uses it. So in a way, it's not suitable for smaller development teams. And it's pretty hard to keep your code consistent if you have some kind of shared code repo or some kind of shared types that you share across your stacks. But that does not mean that you should not use microstacks on your project. In fact, here are some of the best tips that I actually can give you if you are looking on to splitting your core infrastructure, your entire monolith application onto a microstacks. So for example, if you are using microservices, you could use one stack per service. So that way you have complete independence of the service. So that way you can ensure that only the required developers have access to that service. So in a way, it actually falls in line with your microservice architecture as well. So that's one point. And the second point is, if you notice that in a particular project that your deployment times get too long or your resource counts gets really high, then it might be time to start splitting your stacks or your project into stacks. So you can split it up in the ways that I discussed. You can either have your core infrastructure, or you could have per microservice, or you could isolate it on the importance of the infrastructure. So for example, if you have a really, let's say that this infrastructure does not go on par with the rest of it. For example, like a VPC and a DynamoDB table, they don't have much correlation with each other. So what you can do is you can have these kind of infrastructure on a different project, on a different stack, and manage them independently of each other. So these are some of the ways. I mean, there are different ways that you can choose. Your organization might choose a different way to adopt microstacks, but as long as it gets the job done for you, I suggest you go for it when you're splitting microstacks. So I think I spoke for a while, so I think that's about time. I think it's about lengthy topic. So I think I'll just get right on to a demonstration. So here we have a small application, a small serverless backend where we have an API gateway with 3 Lambda functions. And we have a DynamoDB table that is used by these Lambdas. So what we'll do is we'll create our DynamoDB table on a separate stack. And we'll also have our API gateway with the 3 Lambdas on a separate stack. And we'll exchange resources from the core infrastructure onto our API. And we'll see how we can use it on our microstack application or our microstack serverless backend. So I'll just switch on to my code editor. So could anyone confirm if they are seeing my code editor?
Lakindu, we are still seeing, now you can see that, yes.
Yeah, all clear, all good, right? Yeah, okay. So yeah, I've actually set up a small folder on my desktop. So you can, wait, how do I get this out of the way? I think I just move it like this. Okay, I'll just keep it like this. Okay, so you can decide how you want to do it. But first, I'll just walk you through some of the prerequisites that you need to have. So firstly, I would recommend going to Pulumi documentation and just creating an account on Pulumi. So if I just go to Pulumi and just Google it, so if I just Google it, so you can go and create an account on Pulumi and just get started with it and install the CLI. So I use Mac, so I just go with Brew and I'll just, yeah, thanks. So I'll just install that using Brew. And after you install it, you should be able to run the command. If you run Pulumi, it should show you all of these information and you should be able to get started with your Pulumi projects. And ensure that you have AWS CLI or AWS configurations installed, or you have set up your credentials locally, and then we can get started. So I'll just, yeah, I think that's visible, right? Okay. So what we can do is we can create a project. So what we can do is I'll just create a new directory here. I'll just call it core. Yeah. And then what we can do is we can cd onto the core and we can open that on a new VS Code. So on this, what we'll do is we'll create our new project and we'll provision a DynamoDB table on this. That's all that we're going to do on this. So do that, just type Pulumi new, and that will open up a whole lot of templates that you have. So I'll just go with AWS TypeScript. So I think, did I pass it? I passed it, right? I'll just use AWS TypeScript. That's comfortable for me. And after you use the AWS TypeScript, you can give a project name. So I'll just call this core, and then I'll just call it core infrastructure, and I'll just give a small description on it. And yeah, so this is where it gets interesting. So you can define how many stages you want. So these stacks are basically the stage environment. So you can have like a dev, QA, staging, prod, and etc. So for development's sake, I'll create 2 stages and then I'll tell how you can manage it. So for this, we'll just call the first one as dev. And you can determine which region you want to deploy the dev stack onto. So for that, I'll just use normal US East 1, Virginia. And let's just let Pulumi do its thing and install the dependencies. Yeah, I think my internet is a bit slow, so it might take some time here. So let's just get this up. Yeah, okay. So now we have the dev environment. So we can create another environment if we want. So to do that, what we do is you go to Pulumi stack and we go init. And then we can give another stack name. So for this, I'll just call it stage. These are our two environments. One is dev and one is stage. And what you can do is you can copy this file. So this is basically the configuration for dev. And what we are going to do is we are going to create another configuration file and we are going to use that for stage. And here we can determine our dev stack goes on to US East 1. And I can give stage as easily, I can just give it as AP Southeast 1. So just go to Singapore. So I can deploy two stages or two environments in two different regions pretty easily. And then we can go on to the index.ts and we can just wipe out this boilerplate. Yeah, and then we can just start provisioning the table. So for that, you can just use something like, I'll just call it post table as I put in the architectural diagram there. I'll just call it post table. And first of all, let's just get the Pulumi config. So the Pulumi config is basically, we are trying to talk to this file now. So from there, we are going to talk to the file and we can actually just get the stack, I think. So I think there's a perfect method in Pulumi where you just call Pulumi.getStack. Yeah, that's the method. So you don't need that actually. So that will give us some underlying environment. We are on the staging environment of the dev. So after that, we can directly start provisioning our code. So we can just put const post table and we can just put new AWS.DynamoDB table, and then we can just give a separate stage name for this. So we'll just call it stage and we'll call it post table. And this is pretty straightforward. So usually how you would generally define your table. So you define your attributes. So I'll just call this for simplicity. I'll just call it ID and I'll just give it a type of string. And we'll make this our hash key and we'll set up a billing mode. So let's just assume that you missed it out. Pulumi will actually throw an error during deployment saying that you missed it and just set it and retry it again. So here you can hover over it and you get two options. So you have provisioned or paper request. So I'll just go with the paper request model. And then we can just provision it and it'll work. But now we talked about having to share this table with another one, with another stack. So what we can do is we can export it. So we can just put export const posts table name, and we can do is post table dot name. And once we do that, Pulumi will automatically export the name for us. So to deploy the stack now. So we are on, so I'll just switch on to the dev stage. So Pulumi stack select dev. So that's how you switch to a different stack. And then you can just hit Pulumi up. And then that will actually create a deployment for us. And now see, we can see it's creating a DynamoDB table and it's creating a stack for us. So this is actually the preview. So it will tell us what are the changes that's going to be happening. So now see, it's going to create a table with this dev. So it's going to create it on the dev stack or the dev environment. And then you can just click update and then that will ideally create the table for you. Nice and easy. So yeah, so let's just let it create. Yeah. So yeah, that's done now. So that's one table done. So I'll just demonstrate how you can easily share it across these multiple stacks as well. So you can just switch on to your, we created the stage environment. So we can just call Pulumi stack select stage. And then we can directly run the command Pulumi up again. And then what that will do is it will switch on to this mode. And then that will deploy a table on this region now. So now it's on the stage environment and that will deploy another table on this environment for us. So I didn't even do anything. I didn't even visit the console. I just directly provisioned it onto two different regions with just a single configuration file, just that. So if we navigate onto our AWS console here, I'll just show that. So I'm on US East 1. If I go to DynamoDB, I'll be able to see it. So if I go to table, so here's the dev. And then if I move on to AP Southeast one, I'll have the stage table. Those are in 2 different regions. It's all done and dusted now. So I think that's one stack done for us. So now we can create another directory here. So what I'll do is I'll just create the code, the same folder. I'll just create another directory called API. API, we'll just call it API. Yeah. And then what we can do is, oh, sorry, I think I created the wrong directory. So yeah, mkdir API. Yeah, so that's here now. And we cd onto it. And then we hit code and then open that up in VS Code. And I didn't mention this in the presentation, but across each stack, you can actually have different languages. So you can have this in Java and that in TypeScript. So that doesn't matter. So you can have the same thing in AWS JavaScript or AWS Java. So that's basically defined that is based on your preference. So you can go ahead. These stacks can still talk with each other, even though you use different languages. But to keep things simple, I'll just use the AWS TypeScript template that I was using as before. And I'll just call this API. And we'll just call it API Gateway or API Resources. Yeah, we'll just call it API Resources. And we're going to create another dev stack here or a dev stage. And then we're going to deploy that also onto US East 1. Now, we can create another stack here. We create another environment here called stage. So we can directly add that as well. We can, because we have 2 environments, we can create the same environments here as well. So what we can do is Pulumi stack init and call stage. That will initialize another environment called stage. And we can actually update our configuration file for the stage environment. And then I'm going to deploy that on AP Southeast 1. And that's easy as that. You set it up. But here we need one more resource. So now we want our stack to be able to talk from our core. We have to import these resources onto our API gateway. So for this, what we can do is there's a concept in Pulumi called stack references. So what stack references mean is these stack references are all encapsulated within your Pulumi account. So when you log on to Pulumi will initially give you something like, I think let's just go to the app.pulumi and I'll show that to you. So it creates this kind of dashboard for you where you can, everything that you have within these projects can talk to each other. So these are all some of the projects that I have set up, and we need to consider our organization ID. So our organization ID is this, and this organization ID is given permission by our Pulumi access token that we hit when we initially set it up. We'll have a login, and when that login happens, you'll be given an access token. And that access token is valid within this scope only. And that you can restrict that too. You can perform granular changes, and then you can be like, only this access token can access only this stack or this project. You can do that as well. So what we can do is we can copy our organization ID and head on to our API and create a configuration variable for our API. We'll call it core name, and we'll just paste, org name, and we'll just paste it. So we need this across both our environments because we need to refer the other stack always. So to do after that, we can actually again erase this boilerplate. But here I'll just show you a nice simple directory trick to have your code structured properly. You can have a separate directory called references. So in the references, what I like to do is I like to maintain the set of stack references that I have. So for example, I can just import Pulumi from this, and I'll just get Pulumi. Yeah. And then I'll need to create an instance of the config. So the config is what basically allows us to access our configuration variables. You can do this. And then we are going to need this name. So this org name, we are going to need it in our code. We are going to need to get access to this. So why we do this here is because you can inject these values during your build pipeline. You can directly inject them rather than talking to them through like this. You can inject them to your pipeline so no one can even see what this name is. So for security purposes, you can do that. But for demonstration, I'll just leave it simple. And then you can get your org and you can just put config.require and give the name. And that will actually give an output on this organization name that we have. And then we can create a reference to our other stack. So the way we create the reference is we call new Pulumi.stack reference. And then we have to pass in our org. So that is our org. And then basically what's the project name that we are going to refer from? So here what we are going to do is we are referring from something called co. Something called co is where we are referring from. So you can actually add that onto your stage as well, or you can just leave it like you can hard code it here, or you can add that to config and get it. And then we have to tell which stack or which environment that we're getting it. So to get the stack again, we are going to get Pulumi.getStack. And then we are going to talk to this stack like this, and then we are going to establish a reference. And that's our reference. That's done. So we can export this, and then we can export it, or you can directly get access to the output. So for example, if I want to get the name of the table that we exported from that other stack, we can go ahead like reference.require output, and we can go on to our other project and get this name right here. We can copy this name or this name right here, outputs, and we can paste it right there. And that will get a reference name. So post table ref. So that will give us a reference to our exported value here. So I can export this, and then I can use it in this stack wherever I want. So I'll just create another directory. We'll just call it service. And then what we'll do is we'll have something like index.ts, and we'll start defining our Lambda functions as Pulumi from at Pulumi. And we'll also leverage the crosswork, a Pulumi crosswork library. So because we want the best practices on it, so we can just call Pulumi crosswork with AWS X. And when we do that, it'll give us ready-made classes to declare Lambda functions and all of that. So for example, to define a Lambda function is as simple as you just export an asynchronous function, and we'll just call it create post. And then we want to pass in an event, which is a Lambda event. And then this can be something like, it can be an AWS X API gateway request. So this is directly running on the Lambda proxy integration. So you can set it up like that, and it will resolve a promise of API gateway.response. And what you can do here is you can actually get access to the body. So we can get event.body, or we can pass in an empty string because it comes as a JSON string. So what we can do is we can get this, and we can just pass it JSON pass. And from the body, I'm just assuming that I'll just enter a random name or random information. So I'll just have an ID and a name for a post here. And then we'll just create an instance of document client. So Pulumi natively bundles on our AWS SDK as well. So how we can do that is we just have something like document client. So you don't have to install it separately. Just have const document client, and you can call it new AWS. Sorry, you have to import another library. So you can just import the AWS library. So that's the Pulumi AWS library, SDK. So you can just access the SDK and call DynamoDB and call the document client. Now, this usually we specify a region. So this region is picked up from this. So you don't have to worry about setting it. And after you do that, you can just directly call in. So we can have post, we have the ID and the name. And then what we can do is we can just call document client.put, and we resolve a promise, and we get the table name. So this is actually the post. What did I call it? So we just go ahead onto this post table name ref. So we just get that, and we just call get here, and that will resolve it for us. So we import it, and then we add the item, which is the post. Yeah. And then we can return, since this is a Lambda proxy integration, we'll have to return a status code, and everything has to be done by the Lambda function. So we just return the post here. So that's actually one of our Lambda functions with proper business code on it. So let's talk about how we can add this on an API gateway route. So to add this onto a route, let's just go to our index, and let's create an API gateway. So API gateway is essentially new AWS X. So we are using the crosswork library again, gateway.api, I think, yeah, API. And we can leave it like this because we need to get the stack that we are on, because since we're dealing with multiple environments here. So we can just call pulumi.get stack. And then we can refer the name. We can call it stack. And we can call it sample API. And we can just pass in a routes param here. So this routes param will take in an array of API gateway routes. So how that works is pretty simple. You have an object here. So what you can do is you can have something like a path. So I'll just call this posts, and then method. I'll just give the method as post, and our event handler. So our event handler would be what is invoking this service. So what this resource will ultimately consume. So we are going to have the Lambda function here. So for this, we can get the create post, and we just refer it like this. And wait, let me see why that's not working. Service index. And then you can directly create it. And if you were setting up something like Cognito, you can have a custom authorizer or a Lambda authorizer or anything that you wish. And that's it for our API gateway. But Pulumi crosswork library currently has one bug in it. They're still working on it, I think. So this causes some issues with it. So for this, there's some issues with deployment times, with deployment where the API gateway breaks when it gets a new endpoint. So for that, what you can do is add this REST API args and then add the binary media types, and then just give an empty array on it, and that will resolve the error for you. And then finally, you can export your API gateway URL and then just up it. So you can just Pulumi up. So we'll just switch on to Pulumi stack select dev. And then we can call Pulumi up and see what will happen. So now it's creating a stack for us, which is the API. And then it's creating this sample API. And here, this is interesting. So you see, it creates the Lambda execution role, and then it creates the function, and then it creates all of these IAM role policies. So all of these policies that we need. So CloudWatch, DynamoDB, and all of it is given to us. But you can fine tune this by customizing the Lambda function again. And it automatically creates a deployment for the API. And it also creates a stage. So we all know how problematic that is if you're doing that on the GUI. So Pulumi takes care of that also for us. We can just hit yes. And just let Pulumi do its thing over there. And now the deployment engine is running and it's creating the role for us. So notice how Pulumi is actually executing this in the order that it needs it. So first it creates the role, then it would probably assign the policies, and then insert that onto the function. So you can see the function is the one that's going to be created last here. So it knows the exact order that we are using it as well. So in cases like that, it's pretty helpful for people. So I think it's almost done deploying. So now it's setting up the stage, and this is our execution endpoint here. So we can have another deployment because, like I said, there's a small bug on this that needs to resolve this in a second time. So when we deploy it on the second time, we can have a fully functional API gateway here. So now it's going to update the stage API gateway stage for us. And then it will update the media types and create a replacement. And then we can actually use this URL, and I can launch something like Postman, and we can set it up actually. So if we head over to our AWS console and navigate onto API gateway, so we can see our, sorry, I think I'm in US East one there. Yeah. So let's just let it talk. See, there's our sample API. And if we go on to it, you can see that the post method is already there. So we can move over to Postman. And yeah, we can head over to this post request. And then I think, how did I name it? Posts. So yeah, posts. Yeah, posts. And then we give post requests along with the request body. So I'll just give this sample body here. And then we can hit the post request and see what will happen. So I think this is due to my network issue, but yeah, so we have the response back in our table. We have the response back with the status code 200. And if we just go ahead onto our DynamoDB table, so I should switch back on to US East 1. So you can see that our item is there. So yeah, that's in a nutshell how you can utilize Pulumi and your microstacks and deploy a serverless backend in just, I don't know how long it took for us to do this demonstration, but possibly less than 15 minutes, you can get a fully functional backend up with microstacks and Pulumi. So that's actually what I had to talk about with you all. And all of the code that I actually implemented will be available on this repository. I'll upload it so you can access it. And I think if there is no question, I think I'm done. That's all that I had to present. So I think we can move on to questions if there are any. Okay, so those who haven't registered for the quiz can register for it, because we are having a $50 giveaway for the winner of the quiz on the AWS for the quiz right here.
So Lakindu, if we thank you for the informative session, and if we don't have any questions, I think we can move into the quiz. So guys, if you haven't registered, you can quickly register for the quiz using through the Confab platform. So without further ado, we will start quiz from the other side. So you will have 20 seconds. There are 5 questions. So you will have 20 seconds for each question to select the correct answer.
Thank you, Dinushanka, for that. Yeah, thank you.